Welcome back. This is video 2 of lesson 5.4. And remember, we're talking about factoring and solving polynomial equations. Now, sometimes you come across a polynomial that is in quadratic form. So what is quadratic form? An expression of the form AU squared plus BU plus C, where U is any expression in X, is said to be in quadratic form. So, if you have 3 terms and your final term is a constant and you have a middle term that has some expression for X, even though this says U here, remember U is any expression in X, and you have a leading term that has twice the exponent, 2 times the exponent of what that middle term has, then you have quadratic form, and you can actually use guess and check, trial and error, or you can use, what was I going to say? The AC method. Now, sometimes this even works if you don't have a middle term, because you might have a difference of 2 squares, a sum of cubes, or a difference of cubes. For instance, we've got 16x to the 4th minus 81. All right. Well, these are still a difference of 2 squares, because x to the 4th is x squared squared. So even though your book labels this as one of factoring in quadratic form, I don't even think you really have to think about it that way. You've just got a difference of 2 squares. Okay, 16x to the 4th can be written as 4x squared squared, because 4 squared is 16 and x squared squared is x to the 4th. And then 81 is the same thing as 9 squared. So you've got a difference of 2 squares. Here we're just checking to see if the difference of 2 squares pattern fits. Okay, and it does, which is great, because otherwise we wouldn't be able to factor this. So we're going to do difference of 2 squares, and it turns out we're going to do it twice, because when we do it the first time, using our first set of bases, we have 4x squared plus 9 times 4x squared minus 9. Well, 4x squared minus 9 is a difference of 2 squares, as you can see right here. I'm showing you that the pattern fits a second time. Now remember, a sum of 2 squares is prime. Okay, we look for dots, docks, and socks. Well, we all know what dots are. We all know what docks are, doctors, and then we all know what socks are, but there's no such thing as socks. So sum of 2 squares, you can't factor. We don't even look for them. But 4x squared plus 9 is a sum of 2 squares, so we just leave it alone as prime. We consider the fact that 4x squared minus 9 is 2x, quantity squared, minus 3 squared, and we apply our pattern. So the difference of 2 squares there would factor out to be 2x plus 3 times 2x minus 3. Okay, we've got 2 times p to the 8th plus 10 p to the 5th plus 12p squared. So remember, the very first thing you do is you factor out a greatest common factor, the common monomial. So we can factor out 2p squared. So that leaves us with p to the 6th, because we had 2 times p to the 8th, and we brought out the 2, and we brought out 2 of the factors of p, plus 5p cubed. 10 divided by 2 is 5. P to the 5th divided by p squared is p cubed. And then plus 6, because 12p squared, the 12 divided by 2 is 6, and p squared divided by p squared is just 1. It's all factored out, so we just have the 6. Now, when you look at this, at first you may think, well, we can't factor it, but we can, because remember, this is that trinomial that we're looking for. We've got a constant right here. Even though this isn't x, it's p, you have a middle term, and then you have a leading term that has an exponent that's twice the power of the middle term. Okay, guys, if you hear weird sounds, it's because we have some neighbors who are late, several days late on celebrating the new year and doing fireworks. So I apologize for that. All right, so we're going to factor the p to the 6th plus 5p cubed plus 6, just like we would any trinomial, okay? But instead of having just plain p, we're going to have p cubed. Whatever this middle term has, as far as the variable goes and the power of the variable, we're going to use that in our factoring, in our two binomials. Okay, so we still have our 2p squared. We would do p cubed, just like normally you do x and x or p and p, but this time we're going to do p cubed, and then you're going to look for factors of 6 that add to 5. So 3 and 2. And so look, what would happen if we were to FOIL this? P cubed times p cubed is p to the 6th plus 2p cubed plus 3p cubed, so that's 5p cubed. Our middle terms add up correctly, and then 3 times 2 is 6. And neither one of these are sums of perfect cubes, so we are done. Okay, now we're going to talk about solving polynomial equations. To solve a polynomial equation, try factoring and using the zero product property. Guys, y'all need to know what that means. When someone tells you to do that, you need to know that that means you're going to factor and then set each factor equal to 0. Okay, so let's look at this problem. What are the real number solutions of the equation 3x squared plus 15x equals 18x cubed? Okay, this one doesn't even tell you to use the zero product property or to factor. It is a method you need to be familiar with in order to just be able to solve these kind of problems. So we've got a polynomial. So what we want to do is we want to get everything on one side of the equation and 0 on the other, and we want to try to factor because that is a method for solving equations such as this. So we're going to write the original equation. Okay, we want to move that x cubed term over, and we want to write it in standard form. So that means we want to go from x to the 5th to x cubed to just plain x because it's decreasing degree. So then we start to factor, and the first thing we do is we factor out the greatest common factor of 3x, and then we've got times x to the 4th minus 6x squared plus 5 equals 0. So again, we've got a nice little trinomial. It is in quadratic form because you have an x squared here, x to the 4th here, and 4 is 2 times 2. This, the middle term there tells you what to use in each of your factors. So we're going to need factors of 5 that add to negative 6, so minus 5 minus 1. So we're going to have 3x times x squared minus 1 times x squared minus 5 equals 0. We're always on the lookout for perfect square trinomial, dots, dots, and dots. And if you look, x squared minus 1 is a difference of two squares. So we're going to factor that to be x plus 1 times x minus 1. 5 is not a perfect square, so we can't factor it any further. But we can take each of these factors and set them equal to 0. That's using the zero product property. And so we'll have 3x equals 0, x plus 1 equals 0, x minus 1 equals 0, and x squared minus 5 equals 0. So we're going to add 5 to both sides on that one, and then take the square root of both. Take the positive and negative square root. Excuse me. On the others, we just, for 3x equals 0, we divide by 3. We get x equals 0. For x plus 1 equals 0, we subtract over and get x equals negative 1. For x minus 1 equals 0, we add 1 and get x equals 1. And again, we take the square root of both sides, which gives us positive 5 and negative 5. Positive square root of 5 and negative square root of 5. And so that gives us the correct answer of D. All right, we're going to solve a polynomial equation set up from a problem. You're designing a marble basin that will hold a fountain for a city park. The basin's sides and bottom should be 1 foot thick. So see, that's where the little 1 foot is, right there. But remember, on the bottom, it's 1 foot thick too. Its outer length should be twice its outer width and outer height. So the outer height is going to be, say, x, and so is the outer width, and then the length is going to be twice. But that's for the outside. Okay, there's an inside and an outside. Okay, what should the outer dimensions of the basin be? So this x times 2x, if it is to hold 36 cubic feet of water. Okay, so that's giving us information about how big the inside volume needs to be. It needs to be 36 cubic feet. Okay, so the volume of the inside, the interior, is 36. And so the interior length is going to be 2x minus 2. Why? Let's go back and look. Here is the length, 2x, but then you've got to subtract off 1 foot and another foot for the two sides. Okay? The interior width is going to be x minus 2, and the interior height is going to be x minus 1. So let's go back and look at that and see why that makes sense. Okay, here's the width. The outside width is x. But then for the inside, you've got to subtract off 1 here and 1 here. So that's why the interior width is x minus 2. Now, for the interior height, you start off with your exterior height here of x, and there's 1 foot that we need to subtract off for the thickness that's on the bottom. Okay, there's no thickness subtracted off on top, but there is on the bottom. So on the inside, it's only x minus 1 feet high. Okay, we're going to write the equation and put it in standard form, which means we're going to do some multiplying. Okay, we're going to FOIL the 2x minus 2 times the x minus 2. So we get 2x squared minus 4x minus another 2x. So that gives us minus 6x. Minus 2 times minus 2 gives us plus 4. And then we need to multiply by x minus 1. So that's going to give us 2x cubed minus 6x squared plus 4x minus 2x squared plus 6x minus 4. We're going to combine like terms and subtract the 36 over. So let's see, 2x cubed minus 8x squared plus 10x, subtract the 36 over. Negative 4 minus 36 is minus 40. We're going to factor by grouping. First thing we're going to do is take out 2x squared out of the 2x cubed minus 8x squared, and that's going to give us x minus 4. And then we're going to do plus 10 times, well, 10x divided by 10 is x. Then we have our minus, 40 divided by 10 is 4. So now we've got a common factor of x minus 4. And we have left over 2x squared plus 10. They're going to go ahead and have us do the zero product property. So we've got 2x squared plus 10 equals 0. X minus 4 equals 0. Now, guys, I will tell you something that's kind of bugging me. I just went ahead and did this the way that the PowerPoint suggested. I would have gone ahead and factored out a common factor of 2 at the very beginning. But you know what, guys? It's not a big deal. We're going to end up with the same answers. All right. So here the 2x squared plus 10 equals 0. We subtract the 10 over. X minus 4 equals 0. We add the 4 over and get x equals 4. Over here, let's see, we're going to get x squared equals negative 5. And so x is going to be imaginary. When we take the square root of both sides, we're going to get x equals plus or minus I square root of 5. Well, that doesn't make sense. We can't have an imaginary length and an imaginary width and an imaginary height. So here we're going to go ahead and go with x equals 4. So the only answer that's going to work for us is for the basin to be 8 feet long, because remember the length was twice as long as the height and the width, and so 4 feet wide and 4 feet high. Remember, we wanted the exterior measurements. We had to use the interior measurements to find them. Okay, guys, just special thanks again to Larson Algebra 2 and Hope McDougall. They make all of this possible. There's the book I use. Here's my website where I initially get PowerPoints and work from there. So, my Algebra 2 students, make sure you do the problems to try on your own. Make sure you memorize those factoring patterns for sum and difference of cubes, because it's going to be very important that you know them backwards and forwards. Okay, guys, I'll see you in class. Have a great day.